Recorded is rolling. It is Thursday, April 2nd. We're making this today. Newton's wheel, Benham's wheel. One side is Newton's wheel, the other side is Benham's wheel. It showed this to you guys the other day. Ooh. Right. Now, there's a theory for each one of these sides. The Newton's wheel you guys are looking at right now with all these colors, invented by Isaac Newton. Guess what? What did Isaac Newton figure out? If you mix all the colors together with additive mixing, what color does that create? White. Yeah. Oh, actually, you know what? We're kind of right there. Sometimes it works on film and sometimes not because of frame rate and whatnot. Right? But yeah, actually, it's working pretty good. You guys see it turn white. Okay. And then Bennett's wheel, you guys see this is definitely just black and white, right? Just black and white. Okay. Now, this works for some people, but not everybody. And if you give this a spin, because guys, does the color red or the color purple like actually exist out in the real world? Like, are there like red colored molecules? No, it's just like wavelengths of light reflecting against your eyes, and your brain really creates the color, doesn't it? Okay. So we got these different shape, different size lines, and they give this a spin. Right then, yeah, it's the same thing with like going through a camera and frame rate versus seeing it in person. Oh yeah, and as I look down, just like look directly at it, or it's a lot better. I got a video of this too. Let me pull up the video, see if this works. The idea is that colors start to show up. Here, see, I'm gonna just mute this guy and let this guy spin it. So he's got a Benham's wheel. It's the same basic principle that you guys see there. Let's get this thing in motion. Ah, now I can tell you guys what I see, and you may or may not see this, but to me it looks like this inside bands are really dark purple and then red and then kind of a gold color and then green. That's what my eyes see. And if it spins at different rates, then those colors change a little bit. How many of you guys see the colors? Does anybody see colors? You guys see colors? Who sees colors? Right, yeah, some of you guys do. Yeah, usually it's like about half and half. Half the class sees the colors and half the class doesn't see the colors. Yeah, to me those all look like different colored stripes right there. All right, so that's a Benham's wheel part of this. All right, so we're gonna put this together, create this. Okay, of course we're on this fun separately schedule. So that's nice of you. So that. So you guys have some things around. So here's the full page template with what this is probably going to look like. You really only need one of these, so say I'm just gonna work with this one. You guys have some scissors and glue. You guys got some string, and yeah, let's put this together. Okay. Now, obviously you have some excess string. Well, that's not the part of the circles. Guys, go ahead and cut like a rectangle margin. We're going to use this later to make some connectors. You guys see right here, like these. All right, go back to my full picture. Okay, so you guys can see the model picture right in the middle, right? Okay, you guys see the spacers right here. Okay, there's a way you have to put this together, otherwise it doesn't spin right. Like guys, if you just glued the circle next back to back with the other circle and tried to spin it, it wouldn't actually spin along this axis. It would be all like messed up. Okay? So we do have to have these spacers here. How are we going to get the spacers? Oh, because I'm going to cut this rectangle out and I'm going to cut this into a few different spacers. So guys, hold on to this rectangle margin because you're going to need that in a few minutes. Okay, go ahead and cut out the two circles. Two circles. Everybody's cutting out the two circles. Okay. As long as I see that you guys have made one of these, I'll put some points into the grade book for you for creating the Newton's wheel and the Benham's wheel. All right, so cutting out the two circles. Of course, we got this rectangle margin on the side that I'm going to use later. So hold on to that. But got a couple circles.
Sam, is it from these solutions? Classic bridge method. What about that span?
All right, you guys get your circles cut out.
Come on, so oh, you still got it. Oh, why would oh, yeah. It will segment. Fridays, okay, bro. No. Okay, so that's my thing. Use some of my bags. Yeah. Someone from the blue extra. People are talking. No, that's probably like 18 so again.
All right. You guys got some circles. Got some circle. All right. So Let's guys catch up to that. Okay, a couple circles.
All right.
All right. Some of you guys got the two circles. Some of you guys getting really close. Guys get a little closer. We got this session of use that comes on. Oh, yeah. Yesterday, you guys had the in-class quiz on optics. It was a team quiz. You guys could help each other out. Of course, you each had an individual version. Most of you guys turned that in. Some of you guys had to take that home to finish a couple questions and turn that in today. All right, so update on that. If you turned it in yesterday, you already have the points in the gradebook. All right, so right now you guys have two circles. Now, do you guys remember that extra rectangle margin from before? All right, so let's fold this into quarters. So I'll fold them half to like hamburger style and fold them half hot dog style. Right, to get 4 quarters. So I'm gonna have these 4 smaller rectangles. Right. I got those creases. Just cut along these creases. Get these 4 rectangles. Yeah, these 4 rectangles. These 2 circles. All right, make sure you guys got. Um,
This. Both recordings. Did you wish the next thing? What's that one?
All right. Alright, got getting that. 4 rectangles. Guys getting.
Why? When did they have to learn so invincible now?
Yeah.
You just with the purpose of the creases is so you can cut the creases. Okay. So. So everybody's working towards what I got on the projection right now. You got 2 circles, you got 4 rectangle strips, which we're about to use as spacers. Yeah. This that way, or not this way, and then cut those. Alright. Ooh. Right. Right. Next thing I do is I'm gonna take each one of these 4 rectangles and keep folding this in half and make like an accordion shape. So if I go like half, and then half, and then half again, isn't that like eighths? So I just really folded this into eighths, didn't I? Okay. Then I'll unfold that and go back and forth, like a accordion style. Fix it, go back and forth. Like, warning. So there's one. I'm gonna do that for all 4. Fold every one of these into eighths, or each one of these into eighths. Okay, unfold, and then go accordion style on this. Back forth. There's 2 accordion pieces. Three. Final. Four accordion spacers. Four accordion spacers.
I remember the sign. But we go back.
Right. Trying to guide what we're headed towards here. This model picture. Right, so ultimately, I want the patterns to show up on the outsides. Right, so if I flip these over on the other side, so this blank side. Right, these blank sides is where I'm going to glue each of these accordion spacers. And I have four of them, so I'll go ahead and use all four. Now those space around maybe every 90 degrees from each other. Right? You guys see how that's going to glue together like that? See that? Okay. And we'll worry about that red string later. But let's get these spacers on here. Right, so glue time. Right. So go to this one, put it down with glue. Here. Maybe I'll glue them all onto one of these just first. Okay, so one right there. Okay. Then I'll go on the complete opposite side, it's 180 degrees over. Put one right there. Okay. Like I want this to be symmetrically balanced so that when it's spinning around, the center mass is still at the geometric center. And therefore it will rotate more nicely. And then go at the 90-degree mark. You could, of course, measure this out if you want it more exactly correct. If you just eyeball it, should be plenty good enough. And then go straight across from that one. Flip that around. All right, there you go. There you go. For accordion spacers, glued to one of these circles. How about the other side? So throw a dab of glue on each one of these. Then bring in, in my case, Benham's wheel. Just press that down. Ah. You guys have worked with glue in here. You guys know if you just press and hold this for about 10-15 seconds, sure glue. All right, there you go. Okay. So that is coming together. Looks like that. All right, take a trip around the room and so you guys do. All right, pretty good progress here. Yeah. Pretty good, pretty good. All right, these are looking pretty good. So back to my picture model. Then we just got to put on the strings and we'll be all set here. I see in the model, it looks like I have four strings that pass through. You could do this with two or three. Maybe I'll do four just to match the picture. All right, so let's see, where does the string start? That's some end. All right. Well, I want four lengths of string. Probably, let's say about the width of your desk. I think if you go the width of your desk, that should be a good length. Yeah, so there's one string length. There's two, three, and four. There's four string lengths. If you want to just do two strings, it should work perfectly fine. I should remind you guys too why the spacers are on here at all. Okay? Because guys, if this was just flat back to back, okay, and you put the strings through like this and try to spin it, all it would do is it would just flip and then start spinning like this, which would be no good. Okay? So what's sort of the physics behind see why it would actually spin along this axis, which is actually exactly what I wanted to do. Okay? Well, you want there to be more space between the two discs along this axis than there is well, between the two places where you poke holes for the string to put through, right? Okay, so I can't space these holes. I'm about to poke some holes through these discs, right? I can't space them out too wide because I think it's just going to go back to flipping like this, right? Now, also, if they're like too close together, like 2 millimeters apart, probably that paper is gonna tear. Right now, this is cardstock, so it's a little heftier, right? But so maybe it's something like optimal spacing. If you want to measure with a ruler, you could. You guys, of course, have rulers out there. Right? But I'm going to play off this Benham's wheel right here. So it looks like the center would be right here. The center is right there. Right. And maybe I'll go, how about half a centimeter each direction? Right, so let's go half a centimeter that way, bam. Half a centimeter that way, bam. Then turn that 90 degrees, half a centimeter, bam. Half a centimeter, bam. Right. So now I marked out 4 locations. So they're each half a centimeter from the center. Okay. Okay. Well, I have a nice pokey tool right here. Oh, a ballpoint pen. Got my holes punched. Looks pretty good. I go back and reiterate those holes. Okay. All right, and now I'm ready to push my string through. My string through here. Got my 4 strings. String number 1. Okay. Okay, really a good way to get the string through is to just put it right over one of the holes, so then press it through with your pen point. Okay. And there you go. There's 1 string through. 3 to go. 1 down, 3 to go. All right, next string.
Wait, how long should the string?
I would go with the width of your desk. Yeah, so from the left side of your desk to the right side of your desk. What is it about 60 centimeters, somewhere there? I'm not sure. The string is through. Okay. I'll get these aligned as best I can. Right. There's a string that's out of alignment a little bit. You can always chop them down to size, cut them, but try to get these aligned as close as I can here. Pull this one a little bit. Okay. Yeah, that looks pretty aligned right there. All right, so then, all right, make a knot on each end. Let's go around, push through, and tie that up. And if you wanted to, you could always cut them shorter if you wanted to. Chop off a little bit on the other. And this other end, idea. Push this around, tie this off in a knot. All right, that is it. All right. Okay, then to get this going, you could just do this with it, right? And that'll wind it up. And then pull it. All right, there's Benham's wheel on that side. Okay. Now Benham's wheel I found to get this to work, again, it doesn't work as well, I think, through the camera, but in front of your face, it probably work better if it does. Again, it works probably about half the students can see the colors and half not. Okay. But I found like some optimal spin rate. Like if you spin it too fast or too slow, it's like, but if you spin it kind of medium, kind of like a Goldilocks speed, it's like, oh, I can really see the colors. Now, weirdly, and I don't know why this is, but when I spin it clockwise, I see one set of colors, and when I spin it counterclockwise, I actually see different colors on the stripes. Right? I do not know why that would be, but that's just what I see. And then you guys can first try it yourself. Okay? Sometimes these spacers will pop out like this, right? So you just pop this back in. But yeah, but it is spinning along the correct axis, so that's nice. Okay? And if I flip this over, okay, I got Newton's wheel. That's working really good. Wait, why is that working better than before? Huh. Yeah. So outside. That's why I said. Yeah. All right, so there you go. You guys got Newton's wheel, Benham's wheel. Yeah. So I'll walk around, help you guys out, give you guys some points, and I just gotta wait for the pep rally.